Zeroth law. If an object A is in thermal equilibrium with object B, and object B is in thermal equilibrium with object C, then object A and object C are both in thermal equilibrium. Thermal equilibrium means that two objects have the same temperature, which also means there is no net heat exchanged. First law of thermodynamics. This states that energy can't be made nor destroyed, only converted or transferred. It is expressed as the change in U being the internal energy is equal to the difference between Q being the heat added and W being the work. Also, Q would be positive if heat is being added to a system, and if heat is being removed, Q is negative. Now if the work is done on the surroundings, W would be positive, and if work is done on the system, then negative. Second law of thermodynamics. This states that the entropy of an isolated system can't decrease spontaneously. Entropy is the measure of disorder in a system, or in simple terms, the spread of energy in a system. For example, we have an object like ice. It has lower entropy because its molecules are arranged orderly and less disordered. But as it melts, the entropy or disorder increases. Also, there's another definition of the second law, which is that heat can't spontaneously flow from cold to hot. Let's say you have a cold object and a hot object put together. The heat energy from the cold object can't flow to the hot object spontaneously. Instead, the heat energy of the hot object flows to the cold object. Third law of thermodynamics, known as absolute zero, is when the temperature or kinetic energy of a system approaches zero. The entropy of a system also approaches zero. This means in absolute zero. There is no entropy or no disorder, and since the temperature is at absolute zero, the kinetic energy would also have to be zero. Therefore, there would be no movement of the molecules, and it would have only one microstate.